Welcome to Ask and Learn.
This is the answer to Chapter 20, problem number 83 from the Smith Organic Chemistry textbook. This problem asks us to draw a stepwise mechanism for the following reaction, and we're given a hint that conjugate addition can occur with heteroatoms as well as carbon nucleophiles. Okay, so the first step here is going to be this nitrogen nucleophile adding to the double bond here. So those electrons are going to move like that. So after that first step, what we'll have will be this. So we're here. The nitrogen has a positive charge on it. We also have a lone pair and a negative charge on this carbon atom. That was formerly the other carbon in the double bond. And so after this step, we're basically going to have a proton transfer. And so we can just label this as proton transfer. And so once that's happened, that is going to get rid of our charge and get rid of one of the hydrogens on the nitrogen. Not really get rid of, but one of the hydrogens on the nitrogen has shifted to that carbon with a lone pair, so that now the nitrogen is uncharged and that carbon ion is no longer there. And so we'll still have a double bond here, of course. And so basically from here, one thing that might help would be to rewrite this. So remember, an equal sign just means that we're rewriting this. So now rewrite this like this. Okay, so here's our 7-membered ring. Do kind of wish that they could have picked a 6-membered ring instead, right? It would have been so much easier to draw. But so here's our nitrogen that we just added. Okay, and then here is our double bond. And we cannot forget our ketone. Okay, and so basically now this nitrogen still has a lone pair on it. And so this can act as a nucleophile and attack this double bond again. And so after that step, that's going to form our other ring. So we now have this. And once again, our nitrogen is going to have a positive charge, and we'll have a lone pair and a negative charge on that carbon that was formerly part of the double bond. And so with another proton transfer, we can take that hydrogen that is on the nitrogen and put it on that carbon that has a charge on it right now, and that is going to get us to our final product. Okay, and so there we go. There's our final product. This is the mechanism by which it forms. So it's just the nitrogen attacking a double bond, a proton transfer after that. And then the nitrogen has its lone pair back, and so it can again act as a nucleophile and attack the other double bond in this molecule, and that forms the second ring here. And then another proton transfer gets us to the final product. And that's the answer to chapter 20, problem number 83.